Hello and welcome to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in science and engineering education. Today in our playlist of class 12th physics in subject electrostatics, we'll discuss the concept of electric flux and will relate how imaginary concept of electric flux makes calculation of electric field intensity very convenient in symmetrical charge distribution conditions using Gauss's law. Let's start. Electric force lines is an imaginary concept given by Michael Faraday for pictorial representation of electric field phenomena. Now, streams of these electric force lines, or in other words, counting of electric force lines, is called electric flux. Now, the electric flux passing through certain area A, denoted by this black diagram, is the total number of force lines which is passing through this area A, and number of force lines passing per unit area is called flux density or strength of electric field. So we can say electric field intensity is flux density or flux passing through per unit normal area. If phi amount of flux is passing through A area, then flux per unit area is flux density or electric field intensity. Now in the same electric field, if this area is tilted to new position shown by this brown diagram as A dash by an angle theta, we found that amount of flux passing through this new position get reduced to psi dash, but since force lines distribution is the same, so the ratio of psi dash and this normal area A dash of total area A remains the same. Here the normal component of this A dash area is A cos theta. Flux per unit normal area on brown surface remains the same as flux per unit area of black surface, and flux per unit normal area is called electric field intensity or electric flux density. So amount of flux is related to electric field intensity, and flux per unit normal area is called as electric field intensity. In an uniform electric field, if area plane surface is placed normal to electric force lines, or we can say area vector which is directed normal to the surface and electric field vector are in the same direction, then flux through an area A placed in uniform electric field can be obtained as product of electric field intensity and area, as flux per unit area is electric field intensity E, and flux through A area become electric field intensity multiplied by area. Now if area vector directed normal to the surface got an angular displacement from electric field intensity, then in that case flux per unit normal area is electric field intensity, and component of this A area normal to electric force lines is A cos theta, and product of electric field intensity and normal area is flux through an area which makes an angle theta. Now this can be expressed as dot product of electric field intensity vector and area vector, and dot product is magnitude of first vector, magnitude of second vector, and the cosine of angle between E vector and area vector. And look, area vector is directed normal to the surface plane as shown here. If a closed surface is placed in an uniform electric field where magnitude and direction of electric field intensity is everywhere the same, then to that closed surface total amount of incoming flux taken as negative and total amount of outgoing flux become equal, and net flux through that closed surface placed in an uniform electric field is always zero whatsoever the shape or size or orientation of that closed area may be. For this closed cylindrical surface, when axis of cylinder is aligned with electric field intensity, the cylindrical surface won't have any flux through that surface because area vector and E vector are normal to each other and cos 90 is 0. So there is flux only from top surface and bottom surface, and if surface area of top and bottom is A, then at bottom side E vector in red arrow direction and area vector normal to the surface and outward got 180 degree angle, and cos 180 is minus 1. So the net flux through this bottom area is minus EA, or we can say incoming flux is taken as negative. Similarly, at this top surface both E vector and area vector are normal outward and in the same direction. So net flux which is outgoing from top surface is E into A. So net incoming flux negative, net outgoing flux positive are equal and opposite. So total flux from this area is 0. Now it is important to understand that uniform electric field is that field where inside this enclosed surface area there is no source charge exists. So this closed surface is free from any charge source and placed in an uniform electric field, then net flux from this surface is zero. If this cylindrical surface got a different shape, size or orientation but placed again in an uniform electric field, then also net flux from that closed surface remains zero. Here a conical cylindrical surface is placed where base surface area A1 is smaller and this second surface area A2 is higher, and this axis of cylinder aligned with electric field intensity, and we have to find out net flux through this conical surface. We know net flux from any closed surface placed in an uniform electric field is always zero. Here at surface A1, electric field intensity vector shown by a red arrow and area vector normal to the surface and outward shown by blue arrow got 180 degree angle. Cos 180 is -1. So dot product of E vector and area vector is minus E A1 at this A1 surface. Similarly at A2 surface, both E vector and area vector are normal outward in the same direction. Angle between E vector and area vector is 0, cos 0 is +1. So flux through this A2 normal area is plus EA2, and if conical surface side got a flux psi from it, then incoming flux, outgoing flux and conical surface area flux, total flux from this closed surface is 0, and calculation results as conical surface got E multiplied by A2 minus A1 area product flux of negative sign. That means this flux is incoming flux at conical side, and conical side and A1 area side total incoming flux is equal to total outgoing flux of A2 area, or net flux through this closed surface is again 0 as it is placed in an uniform electric field where source charges are absent inside this closed surface. We hope that this informative learning video has improved your conceptual clarity about the imaginary concept of electric flux, and now you understood flux passing through unit normal area directly represent strength or intensity of electric field, and using the basic concept of Gauss law you can relate electric field calculation with its source charge when the charge distribution configuration is symmetrical. We'll meet again with a wish you can work hard, learn a lot and fetch real success in life. Thank you very much.